Hi folks, my name is Emily Weber. I'm a machine learning specialist, solutions architect at Amazon Web Services, and today we're going to learn about Hugging Face on Amazon SageMaker and on AWS. And in particular, we're going to dive into hosting. So this is the third video. Remember, we've got a 3-video sequence. That first one was an introduction to Hugging Face on all of SageMaker. The second one is a deep dive on training, and now we're going to deep dive on hosting. So this is your deep dive. All right, so the good news, my friends, is that you can host any pre-trained Hugging Face model on SageMaker. Let me say that again. You can host any pre-trained Hugging Face model on SageMaker. It's super easy. So for all of those tens of thousands of very interesting, very complex, very high-performant NLP transformer-based models that are sitting out there on the Hugging Face Hub, you can host any of them on SageMaker, and it is desperately easy to do this. So the way we're going to do this, just as we're seeing here, go to Hugging Face Models, and then pick your model. This one is a BERT-based uncased that I was testing around with, and then we're going to click on Deploy, and then Deploy via SageMaker, and then we're going to pick the task. So whichever task you are most interested in, we'll select, and then we'll just pick AWS, and then just make sure you copy that config code. But again, it's going to define your model, the model ID, the tokenizer, the task, and then it actually uses the base Hugging Face inference.py script. So Hugging Face is fully managing the inferencing in that case. Again, it's running on SageMaker, but it's using that inference script from Hugging Face. You can also deploy any of your fine-tuned models that are sitting in S3. So remember in that last video, actually in both the last videos, we were running jobs on SageMaker. We ran training jobs on SageMaker where we pointed to those base Hugging Face models, and then we fine-tuned them using our own data sets. In this case, we're going to point to that fine-tuned model that's sitting in S3, and then we're going to deploy that to a SageMaker endpoint using this Hugging Face model construct. So how does this work, you ask? It's pretty easy. So SageMaker.HuggingFace, import Hugging Face model, check. Got a role, check. You'll see this hub config. Now, if you are using a base pre-trained model straight from the hub, you want to pass in the model ID. You want to directly pass in a model ID. And you're also going to pass in a Hugging Face task. So again, that task name, which in this case is text generation. However, if you are using a fine-tuned model from S3, please don't pass that model ID. Just don't pass that model ID at all. Just don't pass it, and it will perform a lot better for you. It'll be a lot easier. So just don't pass that model ID when you have an S3 model data. And the S3 model data comes in down here. So again, my Hugging Face model is right here, my Transformers version, 4.6.1, PyTorch, and Python versions defined. And then I'm passing in that hub configuration via this environment, along with my SageMaker role, and then I'm defining my model data right here. And so that is a pointer to my pre-trained model artifact that again is sitting in my S3 bucket. So I'm just passing that S3 path right here, and then model.deploy. So in this case, obviously I'm setting up this model using that Hugging Face model object from the SageMaker SDK right here. You can also do this directly from your training jobs. Remember, so when you run that training job and you have that estimator object, as long as it has a finished training job associated with it, you can just do model.deploy really easily. But if you don't have that, and if you're loading from S3 directly or from the hub directly, then you can follow this path. So that is how to fine-tune your model and host on S3. You can also use asynchronous inference with SageMaker. So asynchronous inference is a solution we pushed out last year for larger models and models that don't need inferencing immediately. So if you don't need, within milliseconds response times, you're comfortable with a couple seconds, then asynchronous inference is a better approach. Asynchronous inference will support auto-scaling and supports Hugging Face models. So if you're hosting Hugging Face NLP models, then consider asynchronous inference as an option for the managed queue experience. Basically, if you need a queue sitting in front of your SageMaker endpoint and you want all of that to be wrapped by AWS, then asynchronous inference is the way to go. But maybe before then, I want to think about picking the right instance, actually picking the right ML instance type and size. So this is relevant for every phase of machine learning, but this comes up again and again for hosting. So let's unpack this. So first off, so this ML here in that name refers to machine learning, right? So that means it's a SageMaker instance, basically. Then you have the type of instance. So you'll notice all of the types of EC2 instances follow the same general format, where you have that type of machine, which is the letter, then you have the generation, and a higher number means it's a more recent generation. So G4, G5, P3, P4, basically, again, a higher number is a more recent machine, and it means you are always going to get better performance and better performance for that higher generation. And then the capabilities. So if it's really large, you'll see that those letters here, and then the second dot, and then the size of that machine. Now, different machines are available in different sizes, but you'll see they all follow the same basic construct. So .large, .2x large, .12, .24, .9, .18, etc., etc. For hosting machine learning models, there are typically really about 4 or 5 different types of machines that I'm thinking about. T2 is really only for notebooks. I'm only going to use a T2 or a T3 if I have a model and I'm maybe just developing with my notebook. It'd be pretty rare for me to park an endpoint on a T2. More commonly, I would look at something in the M5 or the C5. The C5 is compute optimized, so you're just going to get snappier compute response times. The M series is sort of more general purpose compute. And so those are 2 sort of middle of the road paths. And then again, they all come in different sizes. So different numbers of virtual CPUs, different memory sizes, etc. And then in terms of accelerated computing, you actually have 3 options. So one option is the P3 series. So those are NVIDIA V100s. And you also have NVIDIA T2s, which is the G4. Actually, T2s. And so both of these types of machines are available. And so it's common for customers to pick between the P3, the G4, and the Inf1, so that AWS custom hardware from Annapurna Labs, Inferentia, is available on SageMaker. And actually, we're going to look at compiling a Hugging Face model and then deploying it onto Inferentia in the demo. So we need to think about our different instance types and then pick the right one and size. And if that's too much work for you, you can also use the Inference Recommender. So we launched Inference Recommender in SageMaker. It has 2 modes. One mode is to find the right instance type for you, where, just as it sounds, we will turn on a variety of instances for you. We'll turn on the C series, we'll turn on the M series, and definitely let you, determine which one is most optimal. The second type of Inference Recommender is actually for the overall endpoint. So defining the number of machines that you want to have, so you can get a sense of what your throughput is going to look like for those machines. On each of the Inference Recommender jobs, the results come back into Studio, and then in Studio, you can, basically we have a little wizard. You can select if you care about latency, or if you care about cost, or if you care about throughput, and then we'll surface which instance is best for your preferences. So that's the Inference Recommender, and it's fully supported with Hugging Face. And with that, let's take a look at the demo. All right. So in this demo, I'm going to compile my Hugging Face model for Inferentia using SageMaker Neo. So remember, Neo is the compilation service within SageMaker that's specific to hosting. So for supported models in Neo and supported operators, you can take your model and then basically, again, compile it to just make it smaller to run more effectively on on-premises hardware, on the edge, in the cloud, and on SageMaker. So let's see how we're going to do this with Hugging Face. So first, we're going to follow the same flow where we're going to install, again, that Transformers SDK. We're going to install SageMaker and then PyTorch. And then we're going to point to a model from the Hugging Face hub. So that's the same Distillibert model we've been seeing throughout the series. And so, again, this is the construct that you should be pretty familiar with right now. So Transformers, again, that's their SDK, .auto tokenizer, .from pre-trained, and then your model name. And so here we're going to load that tokenizer locally and the model locally. So both of those we're going to download from the hub. When you are loading a model onto Inferentia, you need to compile it, actually. And you have two options for compiling it to Inferentia. Option A is Neo, which we're going to look at, which is that sort of managed compilation job that's actually going to show up in the SageMaker console. Option B is using the Neuron SDK. So if you want to install the SDK and execute it locally in order to get that model compiled, you are welcome to do that. In this case, we're going to use Neo to execute the compilation. So both of those, as it turns out, require tracing. So torch.jit tracing, where we need to add in a few more items to run this tracing and then save the traced model. And we'll show that right here. So we're going to create a directory that's just called traced model, nice and simple. And then we need a few things. We need sample sequences, actually. JIT tracing likes to see sample inputs to your model, and then we'll pass that to the tokenizer to pass in, again, this tokenized pair. So we have a few different sequences, and actually they're exactly the same because it's just tracing, and the text input doesn't really impact the tracing so long as it's sort of authentic to your model. And so through that tokenizer, we'll pass in the sequences and the parameters here, returning the PyTorch tensors, and then we'll get this example. So the input IDs and then the attention mask. And then torch.jit.trace, we're going to call model.eval directly inside of this with that example text. So that's loaded into this traced model, and then we'll save that locally in that .pth format. Once that is saved locally, we're going to drop that in S3. So again, session.upload data, we'll drop that into S3. Now, let's take a look at our inferencing code. So there's really one function that matters the most when inferencing. I mean, they're all important. You've got 4 functions for your inferencing script. The model function, which you see right here, picks your model up from disk for health checks, for like SageMaker pings. So when you're calling model.deploy, you need to make sure that this model function is operational. And that's why, again, using Studio locally just to test that function out is a great first step. So again, make sure that model function is working locally, and then drop it into your inference.py script if you want to, not strictly required. But if you want to, you can, again, load it into the inference.py script. So you've got your model function, which is used by SageMaker for health checks. So make sure that that model function is operational. You have an input function, which is accepting the inferencing request. So the input function is looking at, again, the data that's hitting your endpoint and is doing any pre-processing that you need to right there. So inputs, model function, predict. So the predict function takes the outputs of both of those two, your parse data in your model, and just runs your data through the model, so predict, and then output, which sends it directly back to the client. Again, those functions are optional, but if you need to, define more specifically how that operates, then you can bring them yourself. And so in this case, we're obviously bringing them for Inferentia. And so with our inferencing.py script defined, we're going to deploy this. Actually, in this notebook, we deployed to 2 machines. we deploy it onto a G4DN.XL, which is this one, and then we're gonna compare it with the same model deployed onto Inferentia, and then we'll look at the changes in performance. And so first off, so we've got this deploy onto G4. So let's check this out. So again, this one is using that PyTorch model. You can switch that out with the Hugging Face model, totally appropriate. So we'll use the PyTorch model. We got our predictor object and etc. Great, so that's our inference normal.py script and our source directory and then the model name. Actually, this is just the job name. All right, so then model.deploy. And so again, we're deploying that out to a G4DN, and that is one machine. We'll do just some quick predicting. So just, again, we're going to invoke that model.predict, that endpoint.predict right here on our payload, which is predicting that this is a paraphrase. So that's paraphrase detection. And then we're going to compile this model using Neo and deploy onto Inferentia. So this next one is now using that Neuron SDK, again via Neo, BERT sequence classification, still using this PyTorch model constructs. And we're going to trace this model URL. Again, that's the same model that we passed for both of them. So that model data in S3 should be the same for both. Yeah, here we go. Yep, it's the same in both. So the same model data. Great. Inference.py. Except instead of calling .predict or .deploy, we're going to call .compile. So now we're going to take that model and we're going to compile it for Inferentia. So we're going to compile it for inf1. So again, we're specifying our target instance family, which is inf1, defining the shape, the job name, framework version, and then where we want the artifact to go in S3 on completion. Once this finishes, so again, after that model is compiled, we can deploy it onto Inferentia. So then we'll do our inf1 deploy, which is this one. All right, and then we've got our two objects here again, and we'll call the same, that same syntax. So predictor.predict on our payload, which also predicts that it's a paraphrase, right? Because it's the same model. So the question is which one is faster and which one has more throughput and costs less, which is the important one at the end of the day. So this is just some benchmarking content, and I apologize, this is still in dark mode. This is time, and this is the basically the number of requests that we're hitting through. Yeah, there we go. And so essentially, we're seeing that 95% of these requests are less than 91 milliseconds. And the rough throughput per second, so the number of requests that we can respond to in a second is 57. 57.12 seconds. So that's the number of requests. And then here's the same one with a little bit of an easier read there. All right. So the latency pretty concentrated around the 85 to 90 millisecond range. Throughput is around 60 TPS. And that was for that G4. So remember, that was on that G4 hardware. And now we're going to look at the same thing, but with Inferentia. And so another just local function here to invoke the endpoint. And we'll see a big move to the left. So remember, higher latency is further right, lower latency is lower left. And so when we're benchmarking for latency, it's better to be to the left. So we see that for Inferentia overall, the time moved down. And let's see. So now 95% of requests are less than 36 milliseconds. And the throughput is through the roof. The throughput is 165 requests per second. And then here's a bit of an easier read there. So again, move to the left. So here, essentially, we saw that latency dropped to 25 to 30 milliseconds per range, which was a 70% latency decrease, while throughput increased to 220 transactions per second, which was about a 400% increase. And so again, all of that was using Inferentia to deploy onto SageMaker hosting. And so I hope you enjoyed the demo. All right, so some pro tips to close us out here. So the same pattern holds true. Test locally, then scale. When you have a fine-tuned model, when you have a model that has been trained on the Hugging Face Hub, definitely make sure that you're testing it locally. Like, please, 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 try it on your notebook, try it on your notebook instance, try it on your laptop. Make sure that that script operates before you try and turn on your SageMaker resources. So that's pro tip number 1. Number 2, I actually really prefer just using the boilerplate code. Like, it is so much more simple to just point to the Hugging Face code that's already out there, all the solutions that they have, all of the models that they have. Again, they have an incredibly active open source community, so tap into that. Like, ask questions on their GitHub, open issues, look at issues that they've closed. They have a ton of helpful comments out there, so definitely take a look at their code that's available. And it's available not just at the model level, but at the overall use case level. So when you're fine-tuning the model, or when you're solving for question answering, when you're solving for translation, they have these larger scripts that you can run, and they'll import the tokenizer for you, and they'll make sure that it's been tokenized or not, or they'll just run a lot of the content for you. The one addendum to that, I would say, that's specific to hosting is when you need to change hyperparameters on the invocation for hosting. So this happens a lot in text generation, especially. In text generation, when you're working with the GPT-2 models of the world and beyond, the parameters that you pass in can actually really define the type of text that is produced. You can define how creative it is, almost, how diverse the words are. You can define how precise you want them to be. You can define what the lengths of them should be. So the addendum to the boilerplate code tip is to, when you're working with, again, generation models, just spend some time testing out the best hyperparameters for inferencing, and then make sure that you load those in. And then the last pro tip is, again, plan for bias. Plan on bias being in your models. Develop ways to review these. So use SageMaker Clarify to set up notifications. Use SageMaker Ground Truth. Use your boots on the ground experts who can help you figure out, why a model is doing a certain thing, or what the best response is for a customer, and ensure that you're developing these overall system designs that are robust to that type of bias. And with that, thank you very much. Let's go train some models.